Welcome back to Physics with Miyoshi. Today we're going to talk about electric potential energy and a little bit about electric potential. Over here you see a diagram that looks very similar to what we've seen before. We have gravity affecting a mass, and we know that gravitational potential energy is relevant only or related only to its height above a certain point. Now, it doesn't matter if this is the ground or somewhere way above the ground or way below the ground. The only thing that matters in gravitational potential energy is the height difference between any 2 points. So, if you recall, our gravitational potential energy is just our mgh. And so in this case, that h is the difference between here and here, or the difference between here. If we want to find the change in potential energy from this point to this point, we would just find the difference in the heights, h1 and h2. Very similarly, in electric potential energy, we have an electric field that in this case is acting from our positive to our negative charged plates here. So the electric field will be going straight down. We assume that they have no edge effects here. We're looking only at this plate. Maybe it's going infinitely each way, so there are no edge effects. We have electric field going down, pointing from our positive to our negative, and we have a charge here going from point A to point B. Whether this charge is a positive or negative, that's going to affect whether the force acting on it based on the field is going to go down or it's going to go up. So, if you look at this equation here, my force of my electric field is going to be Q0 times E, and if Q0 is negative, it's going to go up. If it's positive, that force is going to go down. So, remembering that little bit of our force and our electric field and our charge, we can see that we can hopefully understand that the next part, that our work that it takes to go from here to here, again, that would just be our distance, force times our distance that we're moving, but the work that goes that the field does to move my charge from A to B, well, that's my electric potential energy at A minus my electric potential energy at B. Well, that we're going to have to know some of these guys, but what we're going to do first is we're going to figure out, well, what is this little guy here? Well, this equation here, the work from A to B, to go from A to B, divided by my charge, that work per charge is the same is equal to my electric potential energy at A divided by Q0 minus my electric potential energy at B minus Q divided by Q0. Well, that is this electric potential energy at A divided by Q is what we call electric potential. That electric potential energy divided by my Q0 is electric potential, which we denote as a V. And it's also very convenient because the V also could be the units, which are volts. Okay, and a volt is a joule per coulomb. And here we have our electric potential energy. We can see that our electric potential energy has to be in joules, like all potential energy or all energy, and our charge is in coulombs. So a volt is a joule per coulomb. And here we have our work done divided by our Q0, our work per charge, if you will, is our electric potential energy per charge at A minus our electric potential energy per charge at B. So, if we think about that a little bit more, we can denote that as VA and VB. And normally we have our change in potential, just like we have in our change in gravitational potential energy. Our change in potential over here is VB minus VA, where we end minus where we start, and that is equal to the negative of the work done per charge to get from A to B. So the work that the electric field does is the negative of my electric potential. Anyway, the nice, neat thing about this whole electric field and electric work and the electric potential is it's very similar to our gravitational model over here, and it helps us to understand just a little bit more about electricity, something where we can't necessarily see our charges, but we can figure out how they work based on our forces, on our work, and this little new thing called our electric potential, which is merely our potential energy per charge. So, that's it for now. Well, a little bit of introduction again about electric potential energy and electric potential. Thanks for tuning in. Hope to see you next time on For More Physics with Miyoshi.